All right, guys, this is the last video. The last problem is 26 through like 33 or something like that. All right, so let's go ahead and get started. We have f of x is equal to x plus 2. We have g of x is x squared. And what we're trying to find is this composition, okay? These composite functions are a two-step process. So the composition is we're going to solve for f of -5 first. And then whatever we get from that as an answer, we're going to put it as an input into g of x, okay? So let's go ahead and start with f of -5. So I'm going to use f of x, and I'm going to build the function. So where x is at, I'm going to leave a placeholder, basically, for this -5. Okay, so we'll put -5 here, and thus f of -5 is equal to -5 plus 2, which equals -3. So this piece right here ended up becoming a -3. And what we're going to do is we're going to now take that answer and we're going to plug it into g of x, okay? So let's come over here and let's build g of x. G of x is x squared. So where x is at, I'm going to leave a parentheses because we're leaving a placeholder. But this is very important because I'm going to put in a -3. So if I put g of -3, it will give me -3 squared. Which if I put this into my calculator, I'm going to get a +9, okay? Because what this is doing is it's taking -3 two times, and it's basically multiplying itself with itself. So a negative times a negative is a positive, and a 3 times 3 is 9, thus giving you a +9. If you're not careful with these parentheses, okay, so the answer on this piece would be a 9. So that means the entire answer, the g of f of -5 will equal 9, and this is how I want you to write it right here as far as the final answer on the test. Now, what I was saying as far as if you're not careful with parentheses and you did not put these two blue parentheses right here and you just wrote -3 squared, with the calculator or people themselves whenever they're doing this by hand, but especially with the calculator, it will verify, is that it interprets PEMDAS. Basically, because there's no parentheses right now, it will interpret the exponential part first, okay? So there's two pieces that are happening right now. The exponential, which is this 3 squared, and this multiplication by a -1. And obviously, because exponents come first, the calculator will interpret this as doing this first. And then whatever you get from that, it would then, because of PEMDAS order, do the multiplication. So 3 squared is 9, and a negative multiplied with this +9 would give you a -9, which is obviously the wrong answer. So please be very, very careful with parenthesis usage all throughout this test for sure. All right, so now let's do a little bit of erasing and make some room for number 27, okay? So number 27, it says, graph the relation and its inverse and use open circles to graph the points of the inverse. All right, so let's first of all graph the relation. So we're going to come over here. We'll say that this is the relation, and we're going to graph it in red. So we'll have 0, 3. There's a dot here. And then we'll have 4, 2. 1, 2, 3, 4, and then up 2. Okay, so if you wanted to label it, you're more than welcome to. And then we'll have 9, 7. So 4, 5, 6, 7, 8, 9. And then 3, 4, 5, 6, 7. And then last but not least, we'll have 10, -1. So that's going to be like way down here. Okay, so at 10, -1. So those are the points of the original relation. Okay, so here's an extension of the x-axis. Here's an extension of the y. And then we have the origin pretty much like right here. So there's a good sketch. And it's asking us to use open circles to graph the points of the inverse. So this 0, 3, all we're going to do is flip-flop, like we did in class, the x and the y value. So it's not going to be 0, 3, it will be 3, 0. So we'll have an open dot right here. And you could put 3, 0 if you like. And not 4, 2, it'll be 2, 4. So it'll be right here. at 2, 4. And then not 9, 7, it will be 7 and then 9. So 7, 8, 9. So it'll go up just a little bit because it'll be 8, 9. And then you could put that flipped as far as notation. And then last but not least, this 10, negative 1 is going to become a negative 1, positive 10, which is going to be about here somewhere. All right. And just like we did in class, guys, inverses with their in contrast with their original function, they will always reflect across y is equal to x. Remember this this diagonal line that we talked about in class that basically looked like this. And you can see these two are mirror images, these two are mirror images, these two are mirror images, and then these two are mirror images. Like we did in class as far as with inverses, having that reflection about the y equals x line. Okay, just a little extra work on that. And that's it. That's all you would have to do on number 27. Now, let's go to 28. 28 is asking us, is the relation, okay, so they're giving us a whole new set of points. So that's why I'm erasing all of this. They're saying, is the relation t a function? Okay, so this right here is relation t. Like all of these values are relation t. And they're saying, is it a function? And then is the inverse of relations t a function? I don't think this should have an s, it's just relation t. All right, so let's go ahead and look at it without graphing it. It didn't ask us to graph it. And remember, I'm trying to see, is there an x value that's repeated? Okay, y values can be repeated all day, but an x value can't be repeated to different y values because it would fail the vertical line test. Okay, for instance, just if I were to graph 1, 2, 3, 4, and then this negative 4 here, 1, 2, 3, 4, that's 4, negative 4. And then if I were to graph 6, negative 4, it'd be 5, 6, and then this negative 4, the point would be here. And you notice it still passes the vertical line test. Like if you had one line that you were scrolling through, like that metal detector analogy we used in class, it's not going to fail in double beep because you have two different x's, not the same x with two different y's. Okay, so if you need to graph this, by all means do so, just to make sure that in fact that it's good to go as far as vertical line test. Another thing you could have done is done the maps that we had from before of how 0 would map to negative 8, how 2 mapped to negative 7, how 4 mapped to negative 4, and how 6 mapped to negative 4. This is okay. This is not failing the vertical line test. And I think you see it more so the way we showed just now on that graph. Let me just do that real quick sketch of that graph just so you can see it. For instance, 0, negative 8 is here-ish. And then you have 2, negative 7 is about here. Not failing the vertical line test still. Okay. And then way over here at 3, 4, negative 4 is about here. And then 5, 6 at negative 4. You see, it doesn't fail the vertical line test if you were to scroll that from left to right. Okay, but now let's look at the relation. So the relation is going to be them flipped, okay? So we're going to say x and y, but then all of these will be flipped. The new x will become negative 8, and the new y will become 0, like on all of these. Negative 7, 2, negative 4, 4, and then negative 4, 6. Now here, if I were to draw a quick map on this, the map would look something like negative 8 is going to 0. It would have negative 7 is going to 2. Then it'd have negative 4 is going to 4, but it would have also negative 4 is going to another number, okay? And another number in this case being 6. So I could, let's say I could write a 6 down here, okay? So negative 4 cannot go to two different y values because then it would fail the vertical line test. And I'll do a quick sketch on that. So we have negative 8, 0, which is about here. We have negative 7, 2, which is about here. And then we have negative 4, positive 4. But then we have negative 4, positive 6. And you see right there, it would fail the vertical line test. So the inverse is not a function, okay? So the relation is a function, but the inverse is not because it fails the vertical line test right here. Otherwise, you could say that the x is duplicated or repeated, or the x maps to two different y values. Either one of those would be correct. All right, so now let's move on to number 29. It says, find the inverse of the function. Okay, I'm going to show you the fast way, and then I'll show you the shortcut way. But let's go, I'll show you the long way, and then I'll show you the shortcut way. Let's first start with a long way. We're always going to change this to y first, okay? Everything else does stay the same. You still have 5x, 5/6x plus 10. The second step is to switch the x and the y. Okay, everything else stays the same, but the placement of x and y will flip, hence the inverse. And then now we're going to try to solve for the new y. Our goal is to get this y, the new place of y, all by itself. So I would subtract 10. So I'd get x minus 10 is equal to 5/6y. And here I have a fraction. Now, some of you might say I could divide by 5/6, but that's a little bit weird the way this all looks. I know this could cancel to a form of 1, but this is confusing. So just like in class when we had fractions, when we want to get rid of them, we're going to multiply by the reciprocal, because then it will create a form of 1. Okay, so we're going to multiply this by 6/5. So 5 times y times 6/5. This 5 on the top will cancel to a form of 1 with this 5 on the bottom. This 6 in the numerator will cancel to a form of 1 with this 6, and we are left with y, all by itself. So that I have 6/5 x minus 10 in parentheses. But this would not be full credit. There's two things that I want to make sure that you understand we want you to do on the test. We want you to simplify this. As we went through the unit, we were allowing you to keep the parentheses, but we now want you to simplify it for the test. And also remember, if you're given y, then the inverse will be y. But if you're given f of x, the inverse is going to be written like this, the inverse of f of x. Let's say that you were given g of x, and you were trying to find the inverse of g of x, you would write the inverse of g of x. It looks like it's g to the negative 1, but that's not how we read it. We read it as inverse of g of x and inverse of f of x. All right, so let's go ahead and finish this piece off real quick. So distributing the 6/5 across the x and this 10, we would get 6/5 x. And if I do 6/5 times a negative 10, and I'm multiplying, just understand this to be like over 1, okay? So that you can know that this 10 is in the numerator and the 1 is in the denominator. So now this 10 and 5 will reduce to 2 over 1. So now we just have negative 2 right here times 6, which would give us a negative 12 on the top and a 1 on the bottom, because 1 times 1 would give you 1. And yeah, we could just write this just as 12, and that would be okay. So this is this piece simplified by distributing 6/5. And again, we're not going to put y, we're going to put the inverse of f of x. And this is the correct notation that we're looking for on the test. All right, so now let's go to number 30. It says, use compositions of functions to explain whether this function here, f of x, and g of x, this one right here, are inverses of one another, okay? So show your work. So basically, remember this proof that we did in class, we're trying to do a composition of what is f of g of x, and would it equal the same as g of f of x? We're trying to see what do they give you if you do both of those compositions. If whatever they give you is the same, then they are inverses of one another, okay? So let's go ahead and begin by doing f of g of x. That means I'm going to take whatever g of x is, which is all of this, and I'm going to put it into the x placeholder on the other function known as f of x. So let's build this real quick. We have 2/3 x minus 6, and like I said, I'm going to take all of g of x, which is all of this, and I'm going to plug it into the input variable into f. All right, so let's go ahead and do that. We have 3/2 x plus 9. So 2/3 times 3/2 is 1, because we know those simplify to a form of 1, and those simplify to a form of 1. So when I multiply, x is left over. But remember, you're going to have to distribute this 2/3 over, because this is addition. There's two terms over here, like two islands, if you will. You're going to distribute this 2/3 over to the 9 as well. So if I do 2/3 times 9, otherwise 9 over 1, you can say 18/3 and then see that you'll get 6. But I want you to reduce as early as possible. And you'll see this skill very useful later throughout the year. So 9 and 3, one's in the numerator, one's in the denominator, will reduce to a form of 3 over 1. Now these numbers are easy. There's 6, there's 1, so it's the same as adding 6. We still have this -6 to worry about, so we're going to subtract it off to where the simplified version of f of g of x, in this case, is going to become just x, because these will add slash subtract and cancel to a form of 0. So I'm left with f of g of x is equal to x. So now, all I have to do now is show what does g of f of x equal. And if it equals x when I simplify, then f of x and g of x are in fact inverse functions, okay? So let's go ahead and make room for that and work that one out. We're going to do g of f of x. So let's take f of x, which is this 2/3 minus 6, 2/3 x minus 6, and we're going to put it this time into g of x, okay? So if I build g of x, which is the outermost function, and now I'm going to put in f of x, which is 2/3 x minus 6, into that x placeholder, if you will. Yes, I'll distribute the same like it did over here. And 2/3 and 3/2 is going to cancel to a form of 1. So I'm left with x. And then this time I'm multiplying 3/2 with a -6. Okay? So think of 3/2 times 6 over 1. Okay? The 6 and the 2 will reduce to a form of 3 and 1. So I'm left with 3 times 3 is 9. And then 1 times 1 is 1. So a positive 3/2 and a -6 will become a -9. Okay? And then I still have this positive 9 to bring down. I haven't worked with that one yet. So I'll just bring this down and I'm adding 9. And sure enough, there's another cancellation form of 0 so that you know you're going to end up with just x from this g of f of x piece. So what you've shown is you've verified. You showed all your work. It's basically the quote-unquote proof, the verification that f of g of x is equal to g of f of x. And again, remember, they don't have to be x. They could be like x squared plus 4 on both of them. As long as they're both the same, then they are inverses of each other. If they're different, then they're not inverses of each other. All right. So now let's move on to our last two problems. We have a piecewise function with 3 different pieces that are defined at certain intervals that you see right here as far as the domains, okay? So let me get rid of this a little bit more. All right. So f of 3 is saying, what is the y value, or what do you get as an answer if you put 3 into this piecewise function? Now, don't let it confuse you, because this is the same as if you were to have written f of x is equal to this first one f of x is equal to this second one, and f of x is equal to this third one. There's three different places or pieces that these graphs exist, but they're all of them are still f of x. So don't let it confuse you, okay? The only thing that we do with piecewise functions is that we don't write f of x all three times. We're going to be a little lazy. You could say mathematicians are a little bit lazy, okay? They just want to write f of x just one time, but that it represents all three of these functions right here. Oops, not that, but this right here, basically where the comma stops, okay? So these will tell you where these numbers belong, okay? Okay, like we said from before, this is that selfie picture, and this is the cropping of the selfie picture. This is the only piece that we want this graph to display. Here's my other selfie, and here's where it will exist, otherwise be cropped out. And then -16 is my last selfie, and this is the interval domain where it will exist, aka be cropped out, okay? So I did find it helpful to show students in tutoring and in class that you can draw three little number lines, if you will, that display what these croppings consist of. Okay, so let's go ahead and do that real quick just to help you out with studying. We have a 3 and we have a -5. Okay, so the way this is going to be shown is x is greater than or equal to 3. So we're going to say like 3 is here on all of them. And then we also have -5 and -5 here. I believe what this was saying is that this should have been -11 to -5. So these actually got switched and are incorrect. So that this first one shows this. Let me show you what I'm talking about. X's that are greater than or equal to 3. Okay. The next one, again, you have -5 and -11. So let's put -5 like right here. And then we'll put -11 like over here. Just so they all kind of like line up, okay? And this can help you if you choose to do it on the test. You just have to work quickly to make sure that you finish in time. So x's are bigger than or equal to -5, so to be closed here, but less than 3. So we're going to open it at 3 and put everything in between. That's the interval that this is showing here. As far as if you were to look at the graph, it would only exist on this domain. The top function would only exist on this domain, and this bottom function of y equals -16 will only exist on this domain here. So it'd be between 11 or -11 and -5. Everything in between, but not touching -5 and not touching -11. So if I asked you, what's f of 3? That means on all this, find x is equal to 3. So x is equal to 3 is right here. And you got to ask yourself, which one is it touching? Well, it's touching this domain. That's where it exists because it's closed right there. So we're going to use the top function for this. So all we have to do is basically rebuild the top function. And where there used to be an x, we're now going to put this input value of 3. So 3 minus 3 would be 0, and if I squared it, I would get 0. So 0 would be the answer for the first one. Okay, and just like good practice, we'll write f of 3 is equal to 0. There's your answer. The next one says, what's f of -11? That means at -11, which is right here, that's where x is -11. Out of all these three, the only one that it wants to be close to is this third one. But because it's not equal to, and it's open, we can't say that it's touching right there on that domain. This one's going to be undefined because it's neither one of these domains will we be able to use to put -11 in there. But negative 10 lies about right here, which ding, 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 you can see it's existing on this third domain. So the function is negative 16. Notice how there's no x values that I can put parentheses anywhere. So that means I can't really plug this negative 10 into anything. So it is what it is. It's exactly what you see as far as just being negative 16 is the answer on that. Now, if we go to positive 10, that's way over here. And you see that if this blue graph or domain of this first piecewise function were to keep going, it would actually hit exactly where 10 would be existing. So we're going to use the first function. Here we go again, rebuilding it. But we're going to put 10 where that x value would be. So I'd put 10 in parentheses where x goes. And 10 minus 3 is 7, and 7 squared would be 49. So sure enough, in good practice, f of 10 is equal to 49. And then f of 0. 0 is somewhere around here between negative 5 and 3. So we're going to use this second function. And 2 parentheses minus 6, we're going to plug in this x value of 0. And 2 times 0 is 0. Minus 6 is a negative 6. So therefore, f of 0 is equal to negative 6. Excuse me, will end up being my answer. So this right here is like the backward process of that problem we just did. All we're going to do is notice we have 1, 2, 3, 4 lines, 4 pieces of lines. So we're going to have 4 different functions as our piecewise function. Okay, so let's go to down here. So we'll say f of x is equal to, and we have 4 different functions. So let's make this fairly big. The first one exists from negative infinity to negative 1. And you can see by the scale that this is the origin and each line is by 1. So we're going to say from negative infinity to negative 1, yes, I could write it like this. But again, I don't want this number in infinity notation. So we're just going to take off the infinity part and only write x's that are less than negative 1, which makes sense on this. Now, we have a choice. We have a choice because this is closed right now. At this corner, it is a closed dot. And we can either put it with the first graph like this and have it open for the second graph right there, but still being accounted for by that red piece, and then looking this way. Or we can make it open for the first one, okay, and then close it for the second one. Whatever you decide, like I'll show you, open for the first one, and then we could close it for the second one. Whatever you decide, just don't double close it because you're going to fail that vertical line test interpretation that we talked about in class, and you're not going to know which piece to use because both of them will have equal, okay? So you have to show how you're wanting to display it, whether it's the equal with the first graph or the second graph. Just don't show it for both, okay? So I'm going to go ahead and show this like if it was closed for the first one, okay? So I'm going to put less than or equal to negative 1. Now, from negative 1, this second piece will exist all the way to 2. And what I'm going to do is I'm going to open both of these, okay? I'm choosing to open it now for this second piece and open it here, which will exist like the following. Between negative 1 all the way to 2, I'm going to say x's that are bigger than negative 1, but less than positive 2. Okay? And then for this third piece, I'm going to close it for the third piece because I have to close it for one of them. Remember, I just can't close it for both. I'm going to say that it's existing between 2 all the way to what looks like 8. So I'm going to choose just to close it for both. So from 2 all the way to 8. So to be closed. And again, y'all's might vary. Just make sure that you see negative 1 is closed there, but it's open here. 2 is open here, but it's closed here. Okay, so just don't double close it. And then finally, the last one is going to be x's that are bigger than 8. So those are my 4 domains that I'm going to like put commas, because this is the list of domains. Remember, it has to look exactly like this on the test, but you don't have to put the domain notation there. And these are the functions here that you would have, the equations, basically the mx plus b's for these lines are going to be written here. Okay, so let's get this first one. This first one is just a horizontal line at 1, 2, 3, -4. So this right here is y equals -4. But again, I'm not going to write y equals because that's what f of x equals. I'm just going to end up putting -4. Okay, this last piece is again y equals -4, but I'm not going to write y equals because that's what this is already accounting for. I'm going to have another -4 for the fourth function. Now I got to figure out what these two functions are in y equals mx plus b form, and I am done. So let's look at the slope. Up 2 over 1. So the slope is 2. And notice this y-intercept is at 1, 2. It's at -2. So this one's easy because I can just write m is 2 and b is a -2. So this is my equation for the second piece, 2x minus 2. Now over here, this is what I was showing you in class when we started the new unit. Let me make some room. We still are going for this y equals mx plus b because they are all lines of the systems of equations. But this one's a little bit different. Let's say I couldn't see where it went to, but I could see at least one of the points that lied on this line. So at 2, 2, okay, at 2, 2, I know that there exists a point. So we could say an xy point exists at 2, 2. And I can see the slope from this. I can see that it goes over 1, down 1, over 1, down 1. So I know the slope is -1. I'm going to use this equation and these two pieces by putting in this x value here, this y value here, and this slope value here. So that I have 2 is equal to -1 times 2, and then plus b. My goal is to find b. So I have -2, 2 plus b. And I add the 2 over to get 4 is b. And now I can do the slope is -1. The y-intercept is 4, aka b is equal to 4. And I could do y is equal to -1x plus 4. And this is the piece that I'm going to put right here. So happy studying, guys. I hope you guys do very well. I'm glad I was able to finish the videos, and I guess I will see y'all next time in class.